The first one, use MATLAB to perform computation for statics and dynamics problem. So I want you to use MATLAB for your statics homework, let's say, your statics practice. Let us use MATLAB for that, so that you are getting used to it. And also, finding solution to differential equation. Do you know what is differential equation?
Yes.
Yes. Where do you heard of it? Calculus and physics. Are you getting to the point where you have to find a solution for differential equation already?
Not yet. Belum. Like officially taught, but
Officially taught in which course?
not yet. I mean.
Huh?
Not yet officially taught.
Not yet officially taught, but in which course you heard the differential equation?
It's through physics.
Physics. Pak Ilham, is it?
Yeah.
Okay. Makes sense. Makes sense. So when you see this equation, y is equal to 5t plus 3 sine 10t. Is this an equation to you?
It's an equation.
It's an equation. To be exact, this is a solution or a behavior of a system that we see. Yeah. But this doesn't tell the characteristic of the system. It doesn't tell the characteristics of the system. The characteristic of the system is told by the differential equation. Okay. And this is just the solution of the system, or we can say this is just an output of the system. And it will change depending on how you you give an input to the system, or how you do anything with the system. Yeah. In mathematics, this is called function. Okay, this is called function. The function maps one number to other number. So, which number that we map to? We are mapping which number to what number? Yeah, we map t to y. Okay. However, when you have an equation like this, yeah, this is not a function as we see this function. Okay, this is the differential equation. How do we find the solution to this? Let's say minus 5. Huh? Move what? Y to the left side. This is already on the left.
I mean, dy with pair with minus 5y.
Y?
With minus 5y into the other side, and the dt goes to the other side.
Why don't you write down dy is equal to minus 5y t?
Different terms. Different variables.
So you want to what do you want to do? You want to integrate this? Left and right to integrate?
Yes.
Oh, okay. Is that how you being taught?
So far. Yeah, so far.
Oh, okay. Yeah. So before we go into that problem, I want to discuss about the homework first. Actually, the homework is too easy. Yeah, because you only do practice on find length, and then there is a max. Yeah. What does find do?
Finding the variable condition. Searches the index.
Searching the index. Yeah. Find is to search the index, and the index will be searched based on the logical expression that you based on the condition, correct? And then what does length do?
It
What's the like of how much elements?
Okay, how much?
Yeah,
How much?
how many elements?
How many elements are in the vector or in the array? Okay. Okay. What about the maximum? Max?
So just like so just the element with the highest
number.
Highest value. Okay. Does it search the index or search the exact value? Is it finding the index or finding the exact value?
value.
Yeah, it's finding the value, yeah, not finding the index. Yeah, the max. The opposite of max is min. What does the min do?
Lowest value.
Yeah, the smallest value. What about the negative value? Will it be also counted in the min algorithm? Yeah, let's say you have uh, an array of -2, 10, 0, 5. If we take min of this factor or this array, what is the result?
It should be negative.
-2, right? Okay, -2. So negative number is included. What about if you have another elements here, -2, comma 0, 0, 0, 0, 0. How many zero you put there, and then the end of it 1. Yeah, it depends whether MATLAB can read it. Yeah.
Yeah.
But if there is a number non-zero over there, this will be the MATLAB that will choose. Depends on the precision on the MATLAB itself. Okay, any question on problem 8.1? No. Problem number 2. In problem number 2, what's the challenge in here? Do you think when you are working on this for the second time? I think second time. What's the challenge?
You mean the difficulty? So,
Huh?
what? You mean the difficulty or the?
Yeah. What's the difficulty? There is no right or wrong. I just want to know what's your difficulty in working on this.
No, because that function has multiple intersections. Right? So what we're trying
Okay.
to do for A is find the intersection, find the x-intercept, right, for the function.
X-intercept. So this one?
To determine whether the rocket hits the ground. Now, but that
Okay.
function has multiple. So selecting that one, the first one, is the hardest.
Okay.
And selecting the first one is the hardest.
Yeah, it tells us to get up to 100. Yeah. And it is good that up to 100 we only find how many intersections? 2 with this one.
Oh, 3 then.
You have 3?
If it's 100, it's
Oh, it's a bit strange because when I say a positive value on this, I got this already.
yeah. If you put it to 200 without including positive value, then it goes down and up, right? So intersection.
Hmm. So the function goes like this, yeah. And then you have to choose the set of time t so that your curve is just showing the positive values of the height. Okay. Once you get that, the rest is easy. Yeah. The same with problem 8.2. Madeline, what's the problem in this case? Oh, when you are working on the homework, what is your difficulty? This one? Cannot understand. No, you don't have to use this one, but your method in working on this. So which part that you find difficult? The first. Oh, the first one. Oh. Line which one? 22.
Fine.
That one.
Find them.
Oops. T positive is
Positive the maximum.
I get the T positive in here, where all of the T here, the H is positive, okay? And then in here is the index, okay? This is the index where the H is the maximum, okay? So I'm trying to get the index in here. After I get the index using find, then I want to get what's the time. So I'm using the T positive. So my T positive constitutes of 0, 2 second, yeah, 2 second, 2 second up to I think 62, 62. Okay, so this is my T positive, and then I want to find out the index where the H is at maximum. Yeah, we get the value of the maximum. Because I want to find out the T, I have the H positive here, yeah. H positive, this is 0 up to some number, I don't know, maybe 3 meters. So let's say I know that the maximum is here. This is about how much? 1,400 here. I want to know what's the time. Okay, what's the time? So the first thing I do is that 1,500 is which index? Which index is this? And I find out on the T positive which index. Make them the same index, and I get what's the time over here. Okay. Okay. Yeah. Any other question on this? Is this clear, Madam? Clear, yeah. Let us move on then. So we have until 10:50, yeah. 10:50. Work on this. Solve using MATLAB.
Okay.
I want the first guy to go work on there. Adrian, work on the whiteboard. Yeah. Using MATLAB. So you write down the codes. Yeah. You write down the codes. Yeah, try.
Have been created. Yes. Itu.
Before working on the problem, we have to understand the problem first.
Statics.
Let us understand the problem. Can anyone Tell me, what do you understand on the problem? What's the understanding?
Statics.
Yes.
Statics.
What do you understand on this problem?
You find first you find the components first.
No. That is method in solving. I want your understanding first.
Understanding as
On the
in
problem first. What is this problem about?
finding resultant and angle.
Okay. That's the instruction. That's what the problem wants you to do. uh, what else? Before coming to that point.
The angle.
Hmm? We have two factors. After that, we are asked to find out the resultant.
Sum, yeah.
Not the resultant, but the factor sum. Yeah, the factor sum. Resultant and factor sum, don't mix them up. Yeah. Okay, your job here is just to add up the two factors. Add up the two factors. Okay. You have two factors, you add up two factors. Okay, Andrian, how to do it? In MATLAB, what do you do?
Yes, find the factor.
Come on.
Define the factor first. Okay, how do we define the factor?
One is equals to 12 cos 60 minus 12 cos.
V1?
That's V1 is done.
Wait, then is 10.
V1 is 10. Okay, let me write down. You define in MATLAB this one. V1 is what?
10 is
10?
we need to use trigonometry or just
Up to you. What's your idea? What's your idea?
4 over 5. And that's 4 over 5.
Sir?
10 times 4 over 5.
10 times 4 over 5. And then?
Comma. So 10 times 3 over 5.
Okay, so this is your choice. Anyone can understand what he means by this?
Yeah.
Yeah. What is the 4 over 5 there?
Angle. Yeah. Basically.
Huh?
Yeah, ratio, yeah. Angle.
Okay, next time you define the factor V1 as the unit factor,
Oh, you.
you multiply by the length. Okay. What's the length of V1? 10. What's the unit factor?
4 over 5.
Yeah, the unit factor is 4 and then 3. You divide by the square root of, okay, and then you multiply by 10. So if I were you, what I will do in MATLAB is, it's not this one, but I will specify factor dummy for number 1. Dummy, I will say 3 and 4 like this. And then I will say UV1 is the, sorry, UV1, which is unit factor of factor 1, will be VD1 divided by norm. Okay, now I get the unit factor already. And then my V1 is just the UV1 multiplied by 10. Okay. This is my choice of method. I want to define the unit vector first, then multiply it with the length. Okay, Andrian, what about the fact V2 here?
To, we need to do unit vector.
Can you find the unit vector? Yeah, how? What's the unit vector for V2? Huh? This is 60 degree, yeah? 60.
Yeah.
Okay, what's this angle?
120.
120. So unit vector,
Cos, 120.
cos 120, correct.
Sin 120.
And sine 120. Okay. In MATLAB, what do you do? UV2, you write down what? Is it cos or cos D? Correct, cos D, yeah. And then sine D. Okay. And then your V2, just the unit vector multiplied by 12. Yep. And finally, your vector V is just V1 plus V2. Okay, what's your answer in MATLAB? Is this the same with your manual calculation? Okay, what's the V just now? You said 18.
3936.
Then
The last number is 3, sir.
3.
3938.
Oh, yes. What about the Y component? Y component? Anyone? Huh?
Yeah.
Oh, that's the Y component. Okay, what's the X component?
The X component is 0.
Really? 0?
0.
It won't be 0. Come on. Do I need to check with my own MATLAB? This is very easy computation. Madeline, what's the result? Really? 0, yeah? Yeah, 0 means your X is over here, yeah? It just go up. Well, let's see. Let's see.
Spanish.
Oh salah, ini kebalik. Balik gak sih? Ini kan kebalik. Matematikanya kebalik. 4 and 3. VD1-nya kebalik.
Oh iya, harusnya X-nya.
Oh sih ya. Dapatnya ini. X-nya 2.
X-nya 2.
Ya.
Oke.
Oh itu kebalik. Ini kebalik. Jadi sektor harusnya 43 atau iya 43 44.
Kan saya tulis 43 di depan.
Tinggal itu 34.
Is it 3, 4?
34.
Iya, 34.
Oh, but I write it correctly here, right? Why is it wrong? Oh, no one telling me.
Anomali.
Anomali.
No one knows.
Masih
No, not this. To be 4 and 3. Okay.
Your brother.
4, 3.
result.
Yeah. 16 point. Berapa tadi? 393. Okay, 393. Yeah. So how do we get the angle theta x? So how do we write this? Is like that lah. That's the v. So this is the angle theta x. How do we get this angle?
And 3/4.
16.39.
Okay, that's one method. The other method that I wanted to use is to use the dot product. How do we use that? How to use this? Okay, we have two factors in here, yeah, factor A and factor B. Let us choose factor A to be this one. What is factor B?
Is
X is 1, 0, correct? Yeah, choose X to be 1, 0. So your cos theta A dot B, which is this, yeah, V transpose times UX divided by V, and then what is the length of UX?
10.
Length.
1.
Length is 1. Okay. Do you understand this? UX in here is 1, 0, yeah. That's the UX. Can you compute that using MATLAB? Find the solution. And then I want you to find out the angle between V1 and V. If you use tangent method, can you find it fast? No. So which is why we are using the dot product. Okay, now finding theta x is easy using tangent. Yeah, you can use tan theta x to be 16. It's 16, right? 3923 divided by 2. So theta x is just a tangent inverse of that. But finding the beta using tangent, not so straightforward. Although you can still do it. You can do it, not so straightforward. But if you use the dot product, you can write it right away. Okay, now you find theta x and beta using dot product. Use MATLAB. Anyone get theta x? Anyone getting theta x?
X is
83 degrees. Okay.
10 is for X direction. There's only one I.
What about beta? Anyone get beta? When you want to find beta, which one is your a factor and which one is your b? We have a and b here, right? Can we use the other way? Sure, of course. So don't be confused. What's your result?
Sorry.
Yeah.
Yang theta X. Theta X 83. Yang beta.
Anyone getting beta 46? 46? Madeline, can you get it correctly? Not yet? Not yet. Okay. Let's wait.
U vector. Because you're projecting the V and U vector.
This one you get it correctly, Madeline? Not yet?
Angle lah.
No, no.
Itu
That one.
Akos.
Okay, let's write down the codes in MATLAB. Yeah, your code in MATLAB will be, where is my
Oh, mau
continuing from there, yeah, continuing from the codes over there. So you define ux first, which is 1 0. You define ux, and then after that you say theta x is equal to, this is cosine inverse, yeah, so you write down a cos d. We want to get it in degree, that is of the whole thing, that is v transpose, I'm using v, yeah, v transpose star ux, and then you divide by norm of the v. That's how you do it. Norm. Brandon, get it correctly?
Yeah.
Gefrat? Philip? You get it correctly?
The
Angle theta x? 83?
Yeah.
Yeah, 83. So if everyone okay? Are you okay also? Getting? What about the beta x? Sorry, the angle beta. How to get the angle beta?
Jadi make it slow.
Yeah, you guide me. Someone guide me beta. Beta equal to
Equals
a cos d of what? Okay, V transpose multiplied by what? Okay, V1 we divide by norm of V1. Okay, this one more. You can also do this. Done. You should get about how much? 40 something?
46.17.
Yeah, 46. Okay. How is it? Is it fun using MATLAB?
It's okay. Just need to get familiar. Yeah.
You have to get familiar
And
with the
also this
syntax.
method because usually for statics
We use the tan thing, the
Hmm?
arc tan for finding angle.
Yeah.
Sort of
That is when you have to the x-axis or y-axis, you can use tan. But if you find this angle beta, cannot use tan. Tell that to Pak Farid, yeah.
well, we'll get flamed.
Civil War. Civil War.
Civil War.
Yeah.
Civil War.
Static Civil War. Central University Static Civil War.
Yeah, if you use the tan method, you cannot automate the computation for arbitrary angle. Arbitrary angle is difficult. Okay, when you write a code in a program, you cannot use tan. Let's move on to the next problem. Everyone get it correctly? 46, yeah, for the beta. Let's move on to the next one. Where is mine? Yeah. Dot product. Yeah, this is just a review. But you remember the theta we have here is the smallest positive angle. Okay. So if this is beta, let's say you want to find out the other angle, you just subtract by 360. Okay, let's say you want to find out the which one? Let's say you want to find out this one, subtract by 360. Okay. It is always the smallest angle. Okay, let's say if you want to find out this angle using the dot product, what do you do? P and unit vector of what?
X.
X.
1
10.
over theta.
Yeah.
Theta.
Yes. Just the same thing that we do here. Yeah. Okay. If you want to find out the other factor, the other angle here, negative 10. Yeah. Any question on this? No. This is angle between the two factors. I will give the handout later. Okay. What I want you to do is just you input these three forces in MATLAB. Do it. Input the forces first.
No. Cuman masuk force-nya dulu.
Yep.
Datangin the moment.
Just
The
input
moment.
the forces.
The moment that they
1, 2, no given angle.
Huh? You can watch the recording later if you want to see. But I need the screen for other writing. Say it again. Unit factor? No. Oh, okay. Yeah. Cos D. If your angle is in the degree, cos D.
Okay.
Okay, let me call a name and then you have to write down.
Yeah, minus 4. Atau you can just use for again. But you specify the direction later in the
Domenico. Where's Domenico? Not here yet. David.
Oh yeah.
David, can you write down the vector for F1? What's F1? Say that again. 600 Newton and then? So UF1, let's say UF1 is unit vector of F1. What did you say? No, unit vector first. The unit vector. The unit vector of F1. Yeah, cos D of what? Okay, 35. Sin D of 35. Okay, and then what is F1 here? UF1 first. 600. Okay, that's correct. What about F2? Gefrat, what's F2? What do I write for F2?
The direction
Okay, the direction. How do we get the direction?
for dot comma 3.
4,3.
Dot comma 3.
Let me write here. Unit vector for F2 is
Yeah. Okay, so first you write for the direction. D2 equals 4.
I don't think I got it. I don't think I got it.
Let me do it.
okay. What is the unit vector for F2?
For F2, negative 4.
So say it again.
Like this, I guess.
F2.
Yes, negative. Kan normnya 5.
What's the unit vector? Oh, D2.
D2 is negative.
Wrong. That's wrong.
Kan ke kiri dia. Negative x-axis. Depends on how you define your coordinates.
Yep. Just now you said what? Minus what?
Minus 4 over 5.
Okay. UF2 is
Minus
minus
4 over 5.
minus 4 over 5 and then
3 over 5.
Minus 3 over.
no, let's not do that.
Yeah. Langsung pakai unit vector. Norm. Yeah.
Use the norm. Let us use the norm. Okay.
Vector dummy 2.
It is good that it is in 3, 4, and 5 arrangement. If sometimes the arrangement is not 3, 4, and 5,
Okay.
you have to compute the norm first. Okay. So write down a dummy vector dummy for F2. We have minus 4 and then 3, yeah.
and then make it
minus 4, 3, and then
divide by norm.
the unit vector. Sorry.
UF2.
UF2, yeah. Oh, unit vector of F2, which is VDF2.
UF2 divided by norm VDF2.
Yeah. Actually, the naming is up to you, yeah.
Yeah.
And I'm just mentioning name now in my head. And so your F2 will be UF2 times the length, which is 500. Okay. The last one.
Get the direction wrong.
Yeah, direction wrong because we said plus 4. It should be minus 4. What about F3?
Vamos gini.
So when
Nah,
so the
Bawah.
so okay, in your head you are drawing this, yeah. You are drawing this. What's this length?
0,2 minus 0,4.
0.2. This length?
That was
0.4. Okay, correct.
it's going downwards only.
minus. Is it going up?
So
It's minus.
you get what the vector dummy first, or you know the length already?
Yeah.
The length, you use the norm, right? This is not the 3, 4, 5 arrangement, so you have to compute the norm. Vector dummy for force 3, which is
0.2
0.2.
negative
Minus
0.4.
Ah, correct. And then unit vector
Unit factor 3
is PDF3.
from
Yes, this time.
Right. And then F3 is just unit vector multiplied by 800. Okay. Anyone have problem using this?
yeah.
Just
With the
throws people off. Just
Yeah.
throws people off it. Because
Okay, now the challenge.
moment.
After you've input all of these forces in MATLAB, find the resultant. How do you get the resultant? Yeah, then you add all of the factor. You see, what's the difference? Now the resultant word comes out, right? You get the resultant of the force by adding up all of the factor. In this case, okay, the resultant force is, you just add up, yeah, F1 plus F2 plus F3. Okay.
Look. No. Something. Oh yeah.
Any question on this? Let's move on to the next problem. Okay, this one.
Combine forces which act on the structure.
You have two forces, P and T, and then they ask to combine. Combine means you compute the resultant. Computing the resultant means you have to add the forces, so you have to input all of the forces. Input P, T, okay?
Yeah, you're gonna find those.
This is important.
Just define
What's the problem here? What's the difficulty you get? Finding the what?
That's
This one. 60 degrees is the CB, right?
is there like
So you have to find out the angle, the alpha.
like sign this sign cos
6 inch is this.
Oh, it's property of cosine. What do you mean propaganda?
geometry propaganda.
Why?
Yes.
Are you? No, you gay.
You actually ratio. What ratio? Yeah, there is 6 and 60.
Brain rot, statics brain rot.
Six cos. Ini kan udah contoh like ya kan sini ya itu kan nanti ya whatever kan kalau sini cos 60 well I'm observing I'm pondering
Let's do the easy part first. Vector P. What is force P? How do you define the P? Ah, P is what? And 100 is.
It was kind of gay and unhinged.
Okay, that's the P.
No, gay.
To input the T, you need to know the angle alpha. Huh?
the angle of here
Angle alpha first.
40. Oh, the height tapi nggak dikasih tahu. Six and six.
666.
Boleh. Tapi nggak dikasih tahu. Mana one six no sih no.
Kita ketemu yang iki garis yang gak miring itu dari cosine roll terus angle-nya kan gak iki.
Apa sih?
This is 60 degree. This is 6 inch.
Even know how to use
Alpha. Let's say the D.
Ini sih like berapa? Ini SAC from B to A.
M. What is the length D here? Okay. So sine 60 degree is D over 6 inch. So your D is, and that's your D. What about M? Yeah, it's the cos, right? Coming from the cos. So following here, your M. What about the alpha? Yeah, a 10 of, not D over M. It's D over L.
Tadi kan dia.
L. This is alpha, right? D over L.
Tadi kan ngomongnya dia L juga.
You said M, is it? Oh, I misheard. I thought it's M. So, and this L, yeah, 3 plus M, okay? Once you get the alpha, how to get the unit vector then for the T? One. Yeah. 180. 180 minus. Why 120 come out? Why using the 60 again here? No, you have already this alpha, right? Okay, what's this angle? What's beta? Okay, what's beta there? Beta is 90 minus alpha. Okay. Does it make sense to you? Beta here is 90 degree minus alpha. And then your angle T is, yeah, is what? Beta plus 90 degree, but this is minus. Okay, this is minus because it is clockwise from X. Yeah, so if we write it there, our unit vector for the T is cosine D of minus beta minus pi over 2. No. 90 ya? Sorry. Pi over 2, 90 degree. Okay, that's our unit vector. What's your method? Hah? Pi plus alpha. Yeah.
You use cos rule.
Of course. You can do pi plus alpha.
Sine rule by the body.
No. I'm saying beta plus 90. Yeah.
Atan.
No, this is not in MATLAB. I mean, when we write in MATLAB, I write it over there as a code. Okay.
Wait, theta is equal to
Sure.
Yeah.
I might use. I think
What's the problem?
I found the resultant, but not in the way you like.
What? That's wrong.
It's wrong. Like
Why you take square root?
no, I'm using cosine rule to find the triangle over there, and then you find an angle using sine rule again, and I it's called I find the other angle by 180 minus the alpha, and then I use this cosine rule to find the resultant using I mean it as a parallelogram, kayak dijajar-genjangin gitu loh, bikinnya kayak
Oh, what exactly that you are doing here?
Jadi kan itu kan saya cari kan itu kan 60 derajat, ini kan otomatis itu kan 120 kan, 120 derajat kan. Nah,
Ah,
saya pakai cosine rule ketemu itunya. Nah, yang dari angle itu saya pakai sine rule.
oh sine 1 is
Terus saya tuh bikin jajar genjang gitu, kayak bikin jajar genjang. Nah, resultan itu jajar genjang. Kan jadi ada kayak
sine 1
bikin jajar genjang lain dia, kayak dibikin.
well, where's the vector then?
yeah what's the
Kenapa?
next no sine x no sine x
No, the R should be a vector, not a scalar.
Nggak bisa skalar ya?
No. It should be a vector, not scalar.
Single, akhirnya maksudnya suruh nyari angkanya untuk
Single equivalent force means one vector only. Okay, one vector only. You find out the magnitude and you find out the direction.
nanti mesti nyari x-nya, x sama y komponennya. Tuh.
Yeah, you have to know what's the x and y component.
saya kan dari
Okay. Students, just be aware, yeah. When you are using MATLAB, you need to know whether you are working with degree or radian. Okay. But in the calculation like this, I'm saying this is cosine 60 degree. Yeah. There is no d in here because this is just my sketching of my calculation. But when you are using the MATLAB, be sure to use the degree or radian. Be consistent with it. Yeah. Okay, you have any problem in defining the unit vector for the t? I wrote it here already. This is unit vector of t. Then the t is 600 times ut. Okay, and after that your r, what is r? Is just t plus p. Can it be p plus t? How about you write down minus of? Can we do this?
Apa itu?
Okay, that's your r. Okay,
Work harder, not smarter.
but where does the r acting in this case? Let's say you find the r. How you draw the r over there? Yeah, the r is coming from here, yeah, because it meets there. The r meets there, so r is coming from here. I just want to test you on your understanding on statics, yeah. Let me ask you this.
aduh
Statics lagi, guys. Statics lagi, guys.
terus lagi nih
Ngerti nggak, guys?
So let's say I have the triangle. This is point A. This is a structure that we have, a structure, and then I have a vector f. The vector f. No. Don't do this. The vector f is going this way. This way. How do you find the moment of vector f about point A?
Oh, F cos angle-nya.
Okay, you projected to this point, and then you multiply by the line. Okay. But the y component, any effect? Zero effect. If I move this vector here, f, to here, will the result be the same?
Yes. I mean, like
Yeah.
Someone say, someone no.
like the force. No, moment enggak. Moment different.
Moment different?
Different, yeah. I mean, tergantung.
Moment different or the same? No, not depending. There is no depending. Is it the same or is it different?
Wait, no.
If I put the force here again, this is the same line, yeah? Same line.
Sama.
Huh? Different moment?
No, technically same line of action, so perpendicular distance kan yang diambil. Kan perpendicular distance sama. Jadi should be same. Oh yeah, should be same, right? The perpendicular distance between the force and the thing is same.
The moment about A is the same, yeah, as long as you move the force along the line of action.
Yeah.
That's the same moment. Okay, yeah. Got you some time to think about it, yeah.
So factor is better. Tadi kamu udah isi, tadi kamu ini.
We still have some time to work on.
It's right. Tadi kamu ini tadi.
Just in time. Use the cross product and solve using MATLAB.
Nanti.
Just get the moment here using MATLAB. What's the formula for cross product?
IJK.
What's the R in this case? What's the R?
R-nya position vector.
Okay, position vector
From O to A.
from O to A, correct. Yeah.
Position vector. Positive ya. I talk with computers, so I can talk more than you talking to other humans. You talk with humans, can you talk with us? Yes.
That's point O. That's point A. So that's your force. This is F. Okay.
Autistic.
40 degree.
Autistic.
Moment about O is
better.
the R cross F. Okay. What's R? From zero. From O to A. Yeah? That's R. R is easy, right? R is just 2, 4. Okay, and F?
600 cos 320.
2, 4. What about F? Yeah, I will write cosine minus 40, sine minus 40, multiplied by 600. Put that into MATLAB and you get the answer. What's the answer? Tell me. Come on. 10 seconds.
Oh my. Okay.
Should be fast.
For F cos D40 sin D40. What is the function for cos again?
Function for cross, anyone remember?
Cross, just say cross.
Just cross, yeah.
Oh yeah, just cross, yeah.
Like the dot product, you write dot of.
Yeah, like
remove this.
how
Remove
like
this one. Remove.
Ini cross nggak bisa. Nah, forum
So to write it in the MATLAB, you write down R
kan harus ada ini.
2 and 4. Okay,
Gitu.
2, 4, and then your F cosine D.
Sir, you forgot to input the zero.
Yeah, the zeros.
For the K.
Okay,
Kurang zeronya, sir.
that's right.
Masalah di
So
crossnya.
what you're doing is that M is equal to cross of R0
Oh
and
iya.
then
Ya.
F0. Okay.
Ya. Boleh.
So the cross product applies for 3 elements. Yeah. So what's the result?
Main tuh.
2.6. Weird because it multiplies by factor of 3.
Oh iya ya. 260 orang ini. Uh, 2609 or 2610. You approximate.
Minus.
Yes.
Yes, I agree.
Yeah.
He's a reform. He's a reform. If you reform,
You
Went from the worst competition to the best.
Wait, but itu menurut faktor tiga. No, if you work too hard, work efficient. No, for one.
So you get minus 4. What does that mean? Minus 4.3. Yeah, in MATLAB says your M in the command window, it is minus 4.3 something. What does it mean? What does it mean?
Oh no, you forgot to multiply by 600. If you get minus 4.3, it's because you did not multiply the F factor by 600.
Say that again?
If you get minus 4.3,
Oh, sorry.
yeah,
I haven't multiplied by 600 yeah.
yeah,
Wait. What's the answer?
it should be like 2.6 times 10 to the power of 3. 2,600.
Minus 2,600.
Paket cancel.
Next week I get
So it's minus 2,600. What's the unit?
NM.
Newton meter. Okay. What does it mean, the minus here?
Clockwise direction. Yeah.
Okay. That's correct. Clockwise, yeah. So what's the magnitude? The problem asks just the magnitude, so it is 2,600. But then the direction is clockwise because of the minus sign here.
Norm
Okay.
norm M.
You get this? Yeah. For moment, when you do cross product, you get minus. It is clockwise. If it is positive, it is counterclockwise.
Norm M.
We still have time. Still have some energy. Cross product review. This is just to review. Yeah, this one. Same thing actually.
Expressing it as a scalar and a vector body. Scalar. Oh wait, scalar tuh just take it kalau misalnya berarti ya zero zero something like that. Oh just yeah.
Okay, you use cross product first to get the moment about O.
Position.
Plus F dong.
Enggak maksudnya harus pakai ini factor. Oh iya harus boleh manual lah.
Forget about the last one first. Get the moment first,
Oke. Moment first.
and then I will tell you how to get the last part using MATLAB.
3 and 5. Of course. Just use it.
The moment about O should be, is it clockwise or anti-clockwise? In this case,
Technically, if it's on O, it should be
it's counterclockwise. The O is over here, yeah, like this. Counterclockwise. Get any number?
What is it? A graph? How did you get the graph? Typing in the interface, not graph in the no plot needed. No plot needed when you have it.
Hujannya di Bandung. Hujannya nggak. PR nggak butuh nanya ya.
Are you done?
Oh,
Getting the answer?
Iya, ada kan?
Dari dia.
2.6 per kilonewton meter, is it?
Yeah.
Okay. You get it minus in there? Oh,
No.
plus. Okay, plus.
How much? Yang tidur.
What moment you get? What's the number? Huh? R. R is from 0 to A, right? That's R. So R is this one, 1.2, 1.5. That's the R. Yes.
Begini kan? Oh ini nothing. Ya. Oh, nah itu. Gimana caranya? Determine the accuracy. Calling of from which moment is zero. You just make absolute zero. Zero. Ya di pusat aja taruhnya. Gak salah sih.
What do you say?
No, to find moment f is zero, just make it zero.
I mean,
No, you find points of X and Y.
it's not exactly wrong either.
So all of you get the moment already? Get the moment, yeah?
Solely on the right. Okay. Yes. Aku bukan momennya di sini.
Ya, ada yang ke bawah.
Still find difficulty in getting the moment? Get the moment already? -2. No, not minus. Should be plus. Should be plus.
Clockwise. Yes, it's plus 7 point.
Yeah.
7.6.
Find unit factor first.
Same thing.
Both are minus. What is going left and going down, right? Left and down. Yeah, positive 2.6. Domenico, you get the answer? Moment.
So ini kan indicate direction.
Wait, what?
I want to make it
Scalar and vector. The 1.2.
This one. Yeah, that's the R. The R is 1.2 and 0.5.
The moment is only get one.
Okay, now we get into the last part of the question. Graphically, where is the location, the moment 0? No lah.
Parah sih. Parah sih.
Location of the moment. Location where the moment is 0 due to this force. Where's the location?
On the line of action.
Come on, come on. Where? It's very clear here. It's very clear. Huh? At where? That's correct. At A, 0. At A, 0. There's no moment at A.
Oh, yeah.
Is that it?
Line.
Is that it? Do you find other places here where the moment is 0 other than A? Huh? No, I'm saying on this figure. Where? Can you mention anything from this figure? Okay, point A is correct. There is no moment over there. You get the answer? Where?
I just understand why.
So late.
What's the moment?
Huh?
What's the moment?
Still asking that, yeah? 2.6. 2.6. 2.6.
Wrong line.
Is it even more later?
Wrong line.
That's correct. Along the line of F, moment is 0. Okay, principally, that's the solution. Okay. Still not answer. Along this line, the moment is 0. Along that line. So, how do we define this line?
I don't know, make y equals to mx plus c.
Correct. Y mx plus c, and then one of the point is this point.
Yeah.
You know what's the gradient m from there, yeah? From here you get the gradient, and then from this point you get the c. So you get that line. So along that line, moment is 0. Now the question is, how do you get that using MATLAB? Any idea? Well, I will really commend you if you can answer this. How do you use your knowledge to use MATLAB to answer the question? Yeah, the answer is correct. It is along this line. Yes. How do you use MATLAB?
This one.
Come on.
Yeah, it's gonna be like some syntax in the library. Yeah, I think
You have to combine your logic and the MATLAB, not just MATLAB. Using MATLAB, you have to use your head, right? No. Manual thing is just the thing that we just did. That's manual. It's not about the syntax, it's the method. The syntax, you do it after you get the method. Now I will tell you the method first.
y minus y1 equals to m.
Where's the eraser?
That one. It's a fine. It's a homework. Oh wait.
So
Yeah, y
moment
-1 lah.
is
Terus
R cross the F, yeah. So R is a point that we want to find out. Okay, R is the point that we want to find.
oh,
Correct? We want M to be what? 0.
yeah,
Yes.
make it 0.
You put it 0, so you make it a variable, and then you cross F that you know. Then your answer will be in variable where you
X
have
and Y.
the relationship between A and B. So this is actually the X and Y. Yeah?
Yes.
You just express Y is equal to how much X from this. That will be the same with the line that we have. Okay. That will be the R.
Y, Y1 is a common way. But X one is the position of F. 1.5.
Graphically, what we are doing is actually this. Okay. So we are assuming that the position of that point is over here. Okay. This is just an assumption. Okay. And then this is the R that we have. Oh, sorry. So I'll tell you, yeah. This is the original R, and that's the R over here, and that's the A, the small a. We want to find out the A. Yeah? Sorry. So your R0 is the A plus R. Yeah. From this equation, you get the R, and then after that, you get the A. A will be R0 plus R. Okay. Minus ya. Minus R. Sorry. Minus R. Yep. Your R, you get it from here, and then you minus it, you get the A. A is our answer. Yeah. So the A will direct you to all of this line. Okay. You understand? Like this. I'm showing it from here. That's the A. All of that line.
Yeah.
Okay.
Line.
That's the line. The A. Okay, I'll see you again next week.